And we're on. Welcome. Oh, jeez. You think I would know by now. Okay, class has begun. Did you hear that? I sure did. Today we are working on rational numbers. Rational numbers look like this. We can have decimals like that, like this. We can have regular fractions that are less than 1. We can have improper fractions whose value is greater than 1. Speaking of which, we can also have mixed numbers, which is just another way to represent an improper fraction. And among all of this, we can also have negative signs, everybody's favorite. And we have different ways of showing division is happening. The fraction bar, the old-fashioned division sign, and multiplying. Parentheses means multiply, and a little dot means multiply. And also our old friend, we don't really use it much anymore. The old X, the multiplication. Oh, excuse me. Just had some yogurt. Yeah, not a good idea right before a video. Okay, I'm going to use a variety of strategies here. They're all good. If you did something different, let's just hope we agree on the answers, okay? If you want to copy these down, you don't have to, but the best thing to do would be to write. Pause that video. Is that the pause sign? Yeah. Okay, if you want to write them, pause the video. Then come back. Welcome back. Here we go. I'm going to simplify my main objective, all of these. Simplify whenever I possibly can. I'm just seeking out opportunities. Because there's nothing worse than getting to the end of a problem with some huge numbers and then you have to simplify. We're going for simplest terms at all times. Not just simplifying, but simplesting. Simplesting? Okay. So here I see some opportunities. I see 3 over 6, which can be simplified to 1 over 2. Do you see that? Even though it's going crossways, you see 3 over 6. Same way here, but coming in from the top and the side, from the northeast. Isn't 5 over 5 the same as 1 over 1? Now, if we just multiply straight across, here I'll use our old buddy multiplication sign. We multiply the numerators. That's the denominator, by the way. Here's a numerator. 1 times 1, what is it? Hey now! And let's make it a little tougher. What's 2 times 1? Very nice. That's beautiful. For those of you out there in YouTube land, this may not matter to you, but this is a answer key, video answer key for a test we just had in 7th grade. Oh, here we go. Do, 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 do. You're welcome. No extra charge for bad singing. Here we go. Like I was saying, this is an answer key for a test we just took in class today. Fresh content. So, let's see. I'm going to work on getting both of these into fraction form. And preferably improper instead of a mixed number, because that empowers us to do this straight across multiply. So I'm going to convert this. What's 5 times 1? Right? Plus 2. Good. So we get 7/5 here. Just converted that to an improper. And now we have this, you might say 2.5, but I like to say 2 5/10. I'm kind of old-fashioned that way. Now when I say multiply, simplify whenever possible, here's what I mean. What's another way I could say 2 5/10? Yeah, I could simplify the 5/10 right away. So I could call that 2.5. You with me on that? I hope so. Okay, now let's take this 2.5 and do what we did over here with 1 2/5. Help me out here. What's 2 times 2 plus 1? And we put it on top of what? We keep that 2. Looks easier now, right? I hope so. It looked kind of difficult there at first, but when you're seeking out all these opportunities to simplify things, things get simpler. Speaking of, I see, just like on our first one here, always pay attention to all your work because you might notice you've already done something. Why do it twice? Why say it again? 5/5 is still 1/1. I don't see anything I can do with 7/2 besides saying there's the result, there's the answer. So 1 2/5 times negative 2 5/10 is negative 7/2. How do we know this was negative after I did all this work with no negative sign? Well, we go up here to the top and we're going, hey, do these have the same sign? And if you're nodding your head up and down, that means yes, they have the same sign, which means it's a positive answer. But if you're shaking your head, no, those do not have the same sign. This one's positive, that one's negative. No means there's a negative sign, so negative answer, okay? Decide before you do the work what the sign is, then do the work, then put the sign in. Here we go, number 3. Ooh, it sure is good to get that mask off for the video. Okay, so here's another way of showing multiplying with the parentheses here. Do these have the same sign? No. I'm shaking my head from side to side. Just like that. That's exactly what I look like. A little bit of hair. Okay, so that means this sign of the answer will be negative. Let's look for simplifying opportunities here. Change color so we can see that more easily. 4/2 is the same as, I heard you back there, 2/1, very nice. Can we do anything with 3/7? No, can't do much with 7 anytime other than multiples of 7, like if you see a 14 or a 21. Then you can simplify, but we can't do that with 3. So I know the answer is going to be negative, and 2 times 3 is 6. And 7 times 1, let me hear you. Okay, cool. Six sevenths, negative. That's number 3. Let's go number 4. Do my best to keep this short. That kind of looks like a weird McDonald's sign right there. It's got the red and the yellow, but what does that mean? Okay, division problem. Division problem. So I'm going to use our old favorite flippin' multiply. In general, I think people out there, talking to you, would prefer to multiply because you just go straight across the numerator and the denominator. What we learned in class, and what you've probably learned before, is if we take a division problem and take the reciprocal or the flip of the second number. So now the denominator is the numerator and vice versa. Oh, but before, look, if you're not paying attention to what you're doing, if you're not trying to simplify whenever possible, you might have missed this. You might just go straight across and go, what's 8 times 9? And you might not know. And then what's 3 times 2? And then you're looking at that going, oh, let's see, I can simplify that. And, oh, I know that that's 12, right? That could have happened to you, and maybe it did. And that's okay, that's the right answer. But check this out. You are going to freak out. What's 8 over 2 simplest form? Right. 4 over 1. What am I going to ask you next? You saw it. You see it coming if you're looking for it. And what's 4 times 3? 12. So we got that answer twice. The old-fashioned way, we just do the math and simplify the big numbers. The new-fashioned way is we try to make everything simple from the very first step. So we change this into a simple 4 over 1 and 3 over 1. Multiply straight across, makes 12. And technically, as the kids like to say, technically there's a 1 on the bottom. So if you have a question asking for denominator and your answer is a whole number, the denominator is always 1 with a whole number. Number 5 out of 6. I promise there will not be any more. Here we go. -3/10. Flip and multiply. Does it matter? Do these have the same sign when we start out? Yes, they have the same sign, which means the answer is going to be beans. We're not going to use the signs in our calculations. Yeah, buddy. But we can simplify 4 over 10 and make that 2 over 5. And we go 3 times 2. Muy bien. 5 times 1. Should I put a box or a circle? Red, green, or purple? Okay, purple circle. Kind of rhymes. Let's go together pretty good. I'm going to highlight that because that was the highlight of that problem for me. Woo! Okay. I'm going to change these to, do these have the same sign? No way. So the answer will be negative. We got to remember that. Let's do the work without a sign. Let's put it back later. 2 6/10 is the same as 26/10, which is the same as 13/5. So we changed the decimal to a mixed number, converted mixed number to improper fraction, simplified improper fraction. Now we're ready to do some work. Let's see what we can do with this. 1 9/15. We can convert that or simplify the 9/15, and we can call this 1 3/5. If we divide top and bottom by 3. And now we can convert this. What's 5 times 1? Good, 5. What's 5 plus 3? 8. So now what it boils down to is it's 13/5 divided by 8/5. Remember, this used to be 2 6/10, and this used to be 1 9/15. Don't forget. So when we multiply, we're going to or divide, we're going to go ahead and change it into multiplication with the little flip and multiply strategy. Ooh, do you see what just happened? Sweet. This problem just got very easy. 5 over 5 is 1 over 1. And then we're going to finish with a bang here. 13 eighths. Got to remember to put that negative sign back. And just in case we need to make this back into a mixed number, well, we can fit one set of 8 into 13, and then we have 5 left over. So we can have a mixed number. We can have an improper fraction. Heck, we could even have a decimal here. That's just one of those fun party tricks. I know all my 8s. What a dork. There we go. So there's all 6 of them. All 6 of them done. Thanks so much for watching. If you did, if you're still here, I'll give you a Jolly Rancher. Ha! Just kidding. Just kidding. I don't have enough. I don't have enough for the billions of viewers out there. Thanks for watching the Witcher Math channel. That's all for today. See you again next time. Bye.